Okay, hi. So this video is the concept or some other ways of understanding the redox equation that we did previously. Now, I'm going to start by saying, I know which of these things is getting oxidized and reduced because the oxidation number of AS is +3. The oxidation number of nitrogen here is +5. The oxidation number of AS here must be +5, and nitrogen here is +2. Do you understand what I'm talking about? Maybe, maybe not. Let's double check the rules of oxidation numbers first. What you see on the screen now are the rules of assigning oxidation numbers to atoms. Any element, for example, starting with number 1, any element has an oxidation number of 0. So this is a pure metal, a solid metal, diatomic gases like oxygen or chlorine. Each of those atoms in those pure elements have an oxidation number of 0. Atomic ion, so an ion with only one element, whatever the charge is, that is the oxidation number. Group 1 and 2, +1 and +2 oxidation numbers, unless they are elements. Hydrogen, +1 with a non-metal, -1 with a metal, though we don't see hydrogen -1 with a metal normally at AP. Oxygen, normally -2, but in peroxides, be careful, if you know the chemical structure to be a peroxide, you can expect it to be -1. In a superoxide, it's -0.5, strangely enough. Fluorine is -1. Now, interesting things. Compounds, which is much more common, you're going to see them a lot more. Neutral compounds, the sum of all the oxidation numbers in a neutral compound must be 0. So for example, NaCl. Na must be +1 because it's group 1. It's a neutral compound, therefore we can assume that Cl, chlorine, is -1. You combine them together, you get 0. For ionic compounds, whatever the charge on the polyatomic ion, you add up the oxidation numbers of each individual element and you will get the charge. If you get that, then you know you've done it correctly. So, back to our board with our oxidation numbers above each element shown. Because this is a neutral compound overall, because oxygen is normally -2, we have -2, -2 times 3 is -6. We have 2 AS atoms, therefore each of them is +3 right now. Nitrogen, we have O3, which is -6. We have a minus charge overall on the polyatomic ion, therefore nitrogen should be +5. Going over to this side, we have H, which is +1, O4, -2 each, so -8 +3. So overall, to make a neutral compound, AS should be +5. And for nitrogen monoxide, a neutral compound, oxygen is -2, nitrogen therefore must be +2. Now, you often get asked questions about what is being reduced and what is being oxidized. Well, you can explain your answer in many different ways. Although you understand oil rig, oxidation is loss of electrons, reduction is gain of electrons. Sometimes that's not inherently clear from the beginning what is actually changing or losing what. So if you assign oxidation numbers to each species, then it's possible to know exactly what is being oxidized, exactly what is being reduced. So here, AS2 +3 becoming AS +5, if the oxidation number is increasing, it is being oxidized. So if the oxidation number increases from some number going up, increasing in magnitude, so not magnitude, increasing. So for example, if a -5 is becoming a -4, that is oxidation. -1 becoming 0, oxidation. 0 becoming 1, oxidation. +3, +5, oxidation. Reduction, on the other hand, have a look at our nitrogen here, +5, becoming +2 over here. So we know that nitrogen, or the nitrate ion, is being reduced. Technically, let's say the nitrogen. The nitrogen itself is being reduced. Oxygen is not changing its oxidation state. It starts at -2 here and is -2 here and here. Therefore, the nitrogen is being reduced. The nitrogen is giving its electrons up. Now, we know reduction as the gain of electrons, but reduction is also a decrease in oxidation number. So you might get asked a question, which is being oxidized, which is being reduced. Other ways you can check or know which species is doing what or is happening to what. Oxidation can also be explained in two different ways. One is the addition of oxygen. So you might look at this and be like AS2O3 becoming ASO4. Look at the ratio of oxygens to AS's here. you can see that for every one AS you have 1.5 oxygens. For every one AS here you have 4 oxygens. It's a fair assumption to say it's being oxidized. On the other hand, the nitrate ion here, the nitrogen here has 3 oxygens. Here it only has 1. Therefore we can know that it is being reduced. Because oxidation is gain of O2. It can be seen as the gain of O2, not every time, but it can be seen as the gain of O2. Reduction can be seen as the loss of O2. Okay? Another way, although this is not true here, so don't be confused by this, but another way you can know for sure about oxidation and reduction in some reactions is about H pluses. Sometimes, if something is gaining hydrogen, then we know that as a reduction, gaining hydrogen. Whereas if it's losing hydrogen, we can know that as an oxidation. Okay? So these are just ways that you can help identify something which is oxidizing or something which is reducing. Okay? Doesn't happen for every reaction. Not every reaction will have a gain of O2 or a loss of A2. Not every redox reaction has a loss of H or a gain of H. But they will always have some form of electron transfer, and you can help identify which species is doing what using the oxidation number system.